Hello and welcome. In the last few sections, we pre-processed data, built, and validated a probability of default model. We learned how to create scorecards and how to monitor the population with respect to the features included in the model. It is plausible to devote so much effort into modeling PD because PD is the most volatile component of the expected loss. Well, now it's time to learn how to estimate the other two components: loss given default, or LGD, and exposure at default, or EAD. Naturally, we are going to start with preparing data for these models. We did some initial data preprocessing for the PD model. First, we turned some string variables, such as employment length and term of the loan, into numeric. Then, we created dummy variables for the categories of some original discrete variables like external grade and purpose of the loan. We also inputted missing values for some variables. Therefore, we can safely use the preprocessing we've already done. So let's load the preprocessed dataset the same way we loaded the initial dataset for the PD model. We can load it into Loan Data Preprocessed Backup Data Frame. It's in Loan Data 2007-2014 Preprocessed CSV file. Then we'll keep this data frame intact in case something happens, and copy the data to the Loan Data Preprocessed data frame. Great! To build models for loss given default and for exposure at default, we need to see the percentage of exposure that was lost after the borrower defaulted and the amount of the exposure at the moment the borrower defaulted. Naturally, these data exist and can be seen only for the accounts that have defaulted. Furthermore, it wouldn't be entirely accurate to include all of the defaulted accounts for modeling loss given default or exposure at default. Why is that? Well, after a borrower has defaulted, they can repay part of the debt, so the lender can recover part of the amount they thought would be lost. Therefore, it is a good practice, when predicting loss given default and exposure at default, to build the models based on data from borrowers that have had enough time to repay part of the remaining debt. In our data, these are only the accounts that were written off. In our dataset, they are indicating as charged off or does not meet the credit policy in the loan status column. By selecting only these observations, we would have chosen the data for building LGD and EAD models. Okay, let's store these data in a new data frame called Loan Data Defaults. In the Loan Data Defaults data frame, we store only the accounts from Loan Data Preprocessed for which the value of the loan status column is charged off or does not meet the credit policy, status charged off. As you can see, there are about 43,000 such accounts. Lots of defaults, eh? The independent variables we are going to use for the LGD and EAD models are the same independent variables that we used for the PD model. Note that in the process of building our PD model, we disregarded many of the initial available variables. Let's see if there are still some missing values in any of the variables we intend to use. First, let's make sure we'll be seeing all rows of the outputs from now on, setting PD options display max rows to none. Note that if your machine cannot handle this, it is not mandatory to do that. Second, let's apply the isNull method to the Loan Data Defaults data frame and then apply the sum method on top of it. If you recall, that is how we counted the number of missing values in each column. Alright, so far so good. There are some missing values in many variables we won't be using, some of which we've actually turned into usable variables. The only two variables with missing values we intend to use are months since last delinquency and months since last record. You may recall from the PD model that each of these variables had a lot of missing values. Back then, since it was necessary to have only dummy variables as independent variables, it made sense to create a dummy variable for the missing values for each of these original variables. Now, LGD and the EAD models are not required to be easy to comprehend since only risk modelers use them. Hence, the independent variables need not be solely dummies. This means we're going to create dummy variables for the categories of the discrete variables, only this time we won't care about the weight of evidence or any other criteria to group the categories. Rather, we'll simply create as many dummy variables as there are categories. When it comes to continuous variables, we can use them in the LGD and EAD models as they are, or transform them if we prefer. Either way, there is no need for the fine classing or coarse classing. Easy. With regard to the variables we discussed a minute ago, months since last delinquency and months since last record, we will include them as continuous in our new models. However, we still have the missing values problem. We will have to impute them. Many circumstances need to be considered when we're deciding how to impute the missing values of such variables. For now, to not complicate things too much, it would be sufficient to just impute them to zeros, taking the most conservative approach to risk. Let's apply the fill_NA method to months since last delinquency with arguments 0 and in place equals true. Similarly, we apply the fill_NA method to months since last record. And that's it. We replace the missing values for these variables with zeros. Well, this is all the pre-processing we need to do for the independent variables. In the next lecture, we're going to create our dependent variables for the LGD and the EAD models.